Today we're going to be talking about how to find the inverse of a 2 by 2 matrix. So I've gone ahead and just given us a generic 2 by 2 matrix here of A, B, C, D. Understand we're talking about the inverse, I'm talking about the multiplicative inverse. And when you're asked to find the multiplicative inverse of something, what that means is you are being asked to take that to the negative first power. So this would be what I've highlighted in yellow here. This is the simple notation for finding the inverse of something. So that instead of having to write out the sentence, please find the inverse of this matrix or something like that, all I really have to give you is here's matrix A, and then just say find A to the negative first. Right? And that should mean the same thing to you of you're being asked to find the inverse. That is the notation for finding the inverse. But anyways, aside from that, your formula to find the inverse of a matrix. The first thing you're going to do is you want to find the determinant of your matrix. Once you find that determinant, you are going to put it under 1. So remember, straight line bars like this are a way of saying determinant, or you can put the DET in front of there for determinant. Either way, you are finding the determinant of the matrix and putting that number under 1. So that's going to create some sort of fraction more than likely. And so then you're going to take that fraction as a scalar, and you are going to be multiplying it to a matrix that is slightly altered from your original. Basically, if you think about our previous video learning about how to find determinants, the way I taught it to you was downhill minus uphill. Right? It's your downhill diagonal of your matrix minus your uphill diagonal of your matrix. Your downhill diagonal is going to switch places inside this matrix, meaning instead of A to D, it will be D to A. Your uphill diagonal will switch signs, meaning you have negative B and negative C. So you're finding your determinant first. You find the determinant of your original matrix. Then, after you've found the determinant and put that under 1, you're going to have this other matrix here that is slightly altered, where you're shifting the place of the downhill and changing the signs of your uphill diagonal. Okay? Let's take a look at an example. We've got a 2 by 2 matrix here of 6, 1, negative 8, negative 2. Let's try and find the inverse of this matrix. Okay? Meaning we are taking this matrix to the negative first power, effectively. So like I said, the first thing we want to do is find our determinant. So our determinant is our downhill diagonal minus our uphill diagonal. Our downhill diagonal would be 6, negative 2. 6 times negative 2 is negative 12. So we are going to take that minus whatever we get from our uphill diagonal. Our uphill diagonal would be negative 8, positive 1. So negative 8 times 1 would be negative 8. If we're taking negative 12 minus a negative 8, that's really the same thing as negative 12 plus 8. Negative 12 plus 8 would give us negative 4. So our determinant is negative 4. Using our formula, that means we would put that negative 4 under 1. So we have 1 over negative 4. And then we're going to build this rearranged matrix to multiply that negative 1/4 into. Right? Do remember that 1 over negative 4 is the same thing as negative 1 over positive 4, and those are both really just the same thing as negative 1/4. So I'm just going to refer to this as negative 1/4 probably from here on forward. So the way we are supposed to rearrange this matrix, we take our downhill diagonal, which again was 6, negative 2, and we switch the places of those numbers. So now negative 2 gets to go in the top left, and now 6 gets to go in the bottom right. Our uphill diagonal was negative 8, positive 1. Those numbers stay where they were, but their signs change. So positive 1 becomes negative 1, and negative 8 becomes positive 8. That would be our rearranged matrix. Now, all we have to do to find our inverse is scalar multiplication, which we've talked about in a past past lesson. All we're doing is taking negative 1/4 and multiplying every number inside the matrix by that negative 1/4. So, if we take negative 1/4 times negative 2, well, a negative times a negative is a positive, and then 2 times 1/4 would be 2/4. Right, I'll simplify in the next step. Negative 1/4 times negative 1, well, a negative times a negative is a positive again, and then we'd have 1/4. Negative 1/4 times 8, a negative times a positive is a negative, and 1/4 times 8 would give me 8/4. That's a bad 8. We'll rewrite that. There we go. Negative 1/4 times 6, well, negative times a positive is a negative again, and then 1/4 times 6 would be 6/4. So now all we have to do is simplify those fractions, and we would have our inverse. 2/4 simplifies to 1/2. 1/4 is simplified already. 8/4 simplifies to 2. That actually divides out evenly. 6 does not divide by 4 evenly, but 6 and 4 can both divide by 2. So we would get a negative 3/2. And so that would be our inverse matrix, meaning taking our original matrix of 6, 1, negative 8, 2 to the negative first power. Taking that matrix to the negative first power gives us this matrix as an answer.